The last 9 chapters have covered almost all core concepts of JSON processing in Snowflake, and this chapter's primary intent to use those concepts and ingest continuous JSON data into Snowflake and see how JSON streaming works. We will learn and practice how to stream JSON data into Snowflake, including data flow approaches and different design consideration when ingesting continuous JSON data. How copy command looks for continuous data ingestion. We covered this concept in chapter 2 in detail. The role of external stage, that is also covered in chapter 2 and chapter 4 in detail. The role of file format, and it is covered throughout the playlist. You can watch chapter 1 and chapter 4. Tracking errors in case of a failure when ingesting continuous data, alternative loading approaches versus using SnowPipe way of ingesting continuous data. Some of the best practices to make sure that you build a robust and resilient data pipeline to process continuous JSON data. We will use Twitter data feed for this example, and this is one of the common use case in the data engineering domain. This example can also be extended for IoT data or clickstream data. This is fully hands-on chapter. If you would like to practice the concept covered in this chapter, please stay tuned until the end, and I will share the link that will allow you to download the SQL script and sample JSON files. Welcome back to my channel Data Engineering Simplified, and to this Handling JSON Data in Snowflake playlist for true data professionals like you. This is a complete playlist covering JSON handling in Snowflake. Links to all chapters can be found in the description section below or by clicking on the information icon above. So let's start chapter 10, Continuous JSON Data Processing in Snowflake. Let's understand the end-to-end data flow conceptual diagram before we start our hands-on exercise. When somebody tweets, data feed is generated and that can be classified as an event. That event should be streamed to S3 bucket. There are different approaches to stream such Twitter feed to S3 bucket. In this example, I am considering S3 bucket as an object storage. However, you can also use Azure or a Google Object Storage technologies and have Azure Event Hub or Google PubSub services to capture those events and save them in the cloud object storage location. Next, in this flow, we will be using SQS notification services that triggers a notification as soon as a tweet JSON file arrives to S3 location. This SQS notification will be queued, and then Snowflake pipe object will process the new arrived JSON file and run a copy command to populate them into Snowflake table. Once this data is available in the Snowflake table, we can create a view or stream and task object to further process them. For simplicity, I am using a view on the top of tweet table and parsing the JSON data into tabular format. Let's try to understand the boundary and scope of this individual component. This is your AWS setup where Twitter JSON files will land and SQS notification will be triggered. This is your Snowflake boundary, and all the configuration and objects are residing inside your Snowflake instance. The Twitter events can be ingested into S3 bucket via standalone program using Python or Java, or you can use some services from AWS. I am going to use a Python program to capture Twitter event and then place them into S3 bucket, and rest of the action will happen automatically if configured correctly. If you have not watched chapter 2 of this playlist where data loading from S3 is covered in detail, including notification configuration, I would request you to watch it. You can also watch the entire data loading playlist that covers every aspect of data loading into Snowflake. There are companies where Kafka technology is used to ingest event data, and Twitter event can be configured as a source, and Snowflake table can be configured as a sink, and Kafka or a Kafka connector can ingest your data directly into Snowflake as soon as an event lands to Kafka cluster. This is one of the alternative architecture and pretty popular. If you are Azure shop, then you can replace it with Event Hub, or if you are a GCP shop, then you can replace it with PubSub services. You can also replace this with serverless components like a Lambda function if you want to batch the processing on hourly basis or a once a day rather than consuming it on real time. If you and your team is not good at programming and cloud configuration, then you can also use tools like Fivetran or a Matillion that can allow you to configure your Twitter as a source and Snowflake table as a target and automatically ingest the data without any complex configuration. For this demo, I am going to follow this architecture. Since I have already covered the S3 configuration in chapter 2 in this playlist, I will not go too deep to explain about them, and I will assume that you are aware how to configure S3 and SQS notification. If you are new to continuous data loading concept in Snowflake and how to process them using ETL, I would suggest you to watch these two chapters, and they will be very helpful to get more clarity. Let's go to S3 configuration followed by SnowSite exercise. Feel free to skip the S3 configuration if you are aware how does it work. Let's quickly create S3 bucket as an external stage. So let's go to S3. So now I can create a S3 bucket. Let's click on create bucket option. So I have given a name called my AWS JSON bucket. I am not changing any option and keeping all the default values as is. And clicking on create bucket. So my AWS JSON bucket is created successfully. My bucket is listed here. I click on the bucket and it takes me to that specific bucket. Now from here, I can create another folder called tweet. So my JSON tweet folder is created successfully. Now there are two changes I need to do on my permission tab. When I come to the permission tab, for a simplicity, we are going to change the permission and make our bucket a public bucket. So for that, I click on this button called edit and I uncheck this box and save changes. It will ask for a confirmation. And it also shows a warning saying that your bucket is publicly accessible. There is one more change which I need to do is by adding the bucket policy to make sure that any public role can access my bucket or list my bucket content. For that, I click on this edit button, and if I'm not sure what to place it, I can click on the policy generator, which will generate a JSON file, and here I will choose my S3 bucket. I will allow all the users. For a simplicity, I will give a star so all users can access that. And I also say all actions. And here I will give the ARN number. Your ARN number is this. You copy the ARN number, come to this screen and say add statement. Now, once you click on add statement, you can click on generate policy and your policy is generated. You can copy the policy and you come and paste your policy here. Once it is done, you can come down and click on save changes. So my bucket policy has been updated successfully and it is now publicly accessible over the network. Now there are one more property you have to define to enable the notification. For that, you can click on the properties and you can create an event notification by clicking on event notification button. Now here I can give any name called JSON event. I can give a prefix or suffix. So I will say JSON tweet. And then I can say star.json files. And then I can say for all object, I can give SNS topic or SQS topic and then specify the ARN number based on my pipe object. Okay. And save changes. And that way we can trigger a notification to Snowflake. I'm going back and uploading a sample JSON file. So I added total 7 files of size 3.6 KB. Let's click on upload. Now all the file uploaded successfully and this is how the status looks like. Now we'll go to SnowSite and try to list them and see how does it look like. I am in my SnowSite web UI and let me quickly change my context. Now let me create an external stage with S3 location. So this is a bucket which I have created for a demonstration purpose. Now let's list all the file available in this bucket and see whether our configuration is working fine or not. So I can see all the JSON files are accessible from my Snowflake account. This is a quick overview how you can configure your S3 bucket. We have done all this step in our previous chapter in this playlist. I would request you to go and watch if you still not sure how to configure your S3 bucket with Snowflake. So this part is configured, and throughout this exercise, I am going to use a Python program to feed the Twitter data into my S3 bucket, which will eventually trigger a notification, and SnowPipe object will automatically consume it through the notification. New worksheet called streaming JSON. Let's change the context quickly. First, I am going to create a file format called my JSON file format where the file type is JSON, compression is auto. Let's create this file format. It is done. Now let's describe how the file format looks like. So my property value for type is JSON. Good. Next, I am going to create a new external stage called my JSON stage, and it is mapped to the S3 location what we have created, and I am attaching my file format, so I don't have to specify the file format again and again. It is created successfully. Let's see how does it look like. So I can see the file format this external stage is referring is my JSON file format, and it is attached to this S3 location. Good. Now let's try to list this stage location. I have done a cleanup and that's why there is no file available. Now let me put some file and let's list them again. Now I can see I have a total 7 JSON file available in my stage location. Now let's run a query on this stage which will print all the JSON content followed by file metadata information. And this is how the query looks like. So this is my JSON content. This is the file name. And this is the time when it is created in the stage location. Again, if you do not understand this column, I would suggest you to go and watch my external table chapter, which covers all the metadata information in detail and how this overall thing function. So let's see how this Twitter JSON data looks like using our JSON visualizer. And let me copy the content first. I can click on this copy function to copy the entire JSON content. It is copied. So this is a valid JSON which has a tweet text, user who has tweeted it, followed by the hashtag and created timestamp. Let's try to see in a visual form. So these are my root elements, and I have entities and I have a user. And then I have a hashtag inside entities, and this is a user mention. And these are the two different elements within my hashtag. These are additional fields which are part of a user. Okay, so this is my JSON object. Now I am going to create a table called tweet JSON table, and this table will not only store my variant JSON data type, it will also store the file name. It will store two additional timestamp. So my table is created successfully. Now I am going to run a copy command which will copy the data into a tweet table, and it will run a select statement from this stage location rather than directly copying everything from the stage location, because I want some additional fields in the table, which is the name of the file, when the file was created in the stage location, and Snowflake scan timestamp. Let's execute it and see whether this copy works or not. So my data loaded successfully without any issue. Looks good. Let me go back to the database menu to see how this copy command looks over there. So this is my tweet JSON table, and I click on the copy history. So all the data loaded without any issue. There are total 6 record. Okay, and I can see total 6 dataset is loaded. Good. Next, I am going to create this pipe object which wraps the copy command, and this copy command wraps the select statement from my external stage. So let's run it and see how does it look like. So my pipe object is created successfully, and now using a Python code, I am going to ingest a lot of data inside my S3 location. Before I run my Python program to fetch the tweet data and put it into a stage location, let's list our stage first. So I have these 7 records. I would prefer to clean them up. So all the 7 files are removed. Now let's list this stage once again. I do not have any data. Now let me go and run my Python program and let's see how the data appears. Now I started my program, and let me run the list command once again. And I can see there are total 56 rows available. Let me rerun. 65, 67, 69, this. So the data is coming continuously into my stage location. Now my pipe object is active, so the data should be populated automatically into my JSON table. Now let's see how the copy command via pipe object is functioning. I come to tweet JSON table and click on a copy history, and I can see the number of records are increasing here slowly. Here I have the loaded data, I have a failed data, and I have a in progress data. And if I scroll down, initially when I ran my automation script, there was some issues, and that's why few record got failed. Now it is continuously ingesting data without any manual intervention. And if I scroll down, this is saying that this is in progress, which is Twitter 3, 12, 11, 40, 42. And if I go down here, it also says that there are possible reasons that something got failed and we can analyze it. And again, if you do not know how to analyze the failure, I would request you to go and watch my previous episode in this playlist. So now let's quickly check the data preview. And this is how the data looks like. Looks good. So I can refresh, and I can also refresh here. Now I can see the record got increased to 190. So data is being ingested automatically. And here you can see this is total 189 and one is in process. If you would like to open the SQL in a worksheet, you can click on this icon. And this is how it looks like. You can really query it and you can analyze the data. Again, if you do not know how the information schema works, I would suggest you to watch this chapter, which covers information schema in detail. So if you look into my program, which is constantly placing the Twitter JSON file into S3 bucket, and here and all the data is being loaded through my tweet pipe. So far 5647 tweet has been loaded and there are 37 failure, one is in progress. Let me refresh it. Now I see 5730. Let me refresh once again. So the data is constantly ingested into the table through the S3 bucket via notification to your copy command using the pipe object. Now let's understand the cost of continuous data ingestion through the SnowPipe. While data is being ingested into a table, I can also monitor the cost of running the pipe. Pipe object needs compute, and that compute is nothing but a serverless service. How do you track and understand how much does it cost to ingest continuous JSON data into a Snowflake? For that, we have to go to admin, and this usage screen shows your total spent. Let's click on compute, and here I can change to hour. And when I click on this account level, it will show me how much credit the pipe has consumed. And when you hover on the green bar, it shows that my pipe has consumed 0.4 credit. You can also check that I have been testing this my pipe and my JSON pipe, and this is what it looks like. You can still click on that, and it will show you how much credit it has consumed. So I have been running for 3 to 4 hours of data set. It is taking 0.4, 0.3 and 0.1 credit, which is really a very small amount. I can really ingest a lot of tweet data in a batch mode in every second rather than inserting individual tweets. That will also reduce my credit consumption cost further. So SnowPipe is a very effective object where you can ingest data at a very fast rate, and once the data is ingested into your Snowflake table, you can build rest of your ETL on the top of it. A view on the top of tweet JSON table, and this is how the select statement looks like. I am selecting the file name, stage creation timestamp. I am using the colon and dot notation to access all the element from my JSON object. So the root element can be accessed through the colon notation, and sub element can be accessed through the colon followed by dot notation. So if I look into the user object, I can access user.name, user.screen and so on. I can access the tweet using the source colon text, which is a tweet text, and I am accessing all the hashtag using the colon and dot notation through this indexing approach. The table has a file name and the stage creation timestamp to see how fast the data is being ingested from the time it actually comes into the stage location. So let me create this views, and this is how the structure of the view. If you do not know the power of view in Snowflake, then I would again request you to watch this chapter, which gives entire detail about standard views, materialized views, and secure views. Let me create this view. So my tweet view is created successfully. Now let's do the count from this view first. So I have 6,139 records, looks good. And let's see the data from the view. This is how the view looks like. I can see all the hashtags. Wherever it is not available, it is coming as a null. And let's try to understand from the time this Twitter feed is created and the time it got ingested. If you look into this timestamp part where it is 11:43:28, here 11:43:29. Okay, so within 1 second, your data set is ingested into Snowflake tables. This is how you can achieve streaming within a second. Certainly, it is not a sub-second because SnowPipe object does not work on a sub-second. However, 1 second is also not a bad number and not a bad latency. So if you have a lot of data, IoT data, clickstream data, or a Twitter kind of a event data, you can use the SnowPipe on the top of your S3 bucket. It will come inside your Snowflake table very fast. Let's quickly understand the different ingestion approaches when it comes to continuous JSON data. As a data developer, if you have to ingest your JSON continuously, you may think what all the different approaches you can apply. Object storage followed by notification is the approach what we have followed and seen. This approach is relatively simple. It does not need a lot of configuration and a complex integration challenges. It's a very cost effective and there is no need to maintain the complex system. We have discussed earlier, if you have a Kafka cluster in your organization, you can also follow a Kafka based data ingestion to the Snowflake. In that case, you need to manage Kafka cluster. You need to create topics and different partitions based on the data volume. You also have to have a Kafka operational cost and you should have the Kafka knowledge. These are the additional overhead compared to the first approach. If your team is not fully aware of Kafka or having challenges with cloud integration, then you can also go with this SaaS platform, which is pretty popular in the market. It is Fivetran or Matillion. They are easy to configure. They are pipeline as a service or ETL as a service. Your team must have some integration knowledge and that I am classifying as an integration cost. However, the same integration cost is also available with your S3 and SQS notifications. Your Fivetran or Matillion as a service will cost you based on your ingestion volume. However, these services are very easy to configure and get your things done very fast. Now let's talk about some of the best practices around continuous data ingestion when it comes to the JSON data. SnowPipe is a serverless compute and very reasonably priced by Snowflake. So use it to simplify your continuous data ingestion pipeline when it comes to JSON data. SnowPipe also tracks the duplicate file, so leverage it. Make sure the JSON file format properties are used correctly. We have covered all the JSON properties in our previous chapter in this playlist. Make sure your copy command properties are used correctly to handle the loading errors. If you are not very confident about loading data and the copy command, I have a complete playlist available which covers every aspect of your copy command and the properties associated with it. So club many individual JSON object as new line delimiter JSON file and your JSON file will carry more and more JSON object and a lot of data can be processed at one go and that will increase your ingestion rate. If possible, use gzip compression when it comes to the JSON files. Add file metadata column in your landing table to understand. So by looking at that dataset, you can further optimize. This is not a very exhaustive list. However, keeping this bullet point in mind, you will be able to build a robust and resilient data pipeline to consume your continuous streaming JSON data. We have learned almost all the key features with respect to JSON data file loading, JSON validation, JSON processing, and JSON streaming into Snowflake. Now, it would be interesting to explore if we can handle Delta data or a CDC when it comes to JSON, and if this concept is even meaningful when we talk about JSON processing. So, don't forget to watch next chapter, chapter 11, which will cover the stream object with respect to JSON data processing. I hope you have been enjoying this playlist and will surely watch the next chapter to learn more about JSON. Don't forget to explore my other playlist, which covers wide variety of topics including Snowflake certification. And if you feel that my content is helping you, please do subscribe to this channel and do share with others. Thank you and happy learning and keep growing.